Hello students, today we will discuss problems in radioactivity. Radioactivity is a nuclear process. So out of four choice, the correct answer is option 1. It is a nuclear process. If the pressure on a radioactive material is increased 3 times, then the mean life of the element, mean life will not affect with pressure, it will not change. The relation of mean life with lambda is this, it does not change. So out of four choice, the correct answer is option 1. A radioactive material emits 20 beta particles per second at 10 degrees centigrade. If the temperature is increased to 20 degrees centigrade, then the emission rate of beta particles per second. Radioactivity remains unaffected by any physical or chemical change. Okay. So the answer to the given question will be option 1. What will happen when a radioactive substance with mean life 2 into 10 power 5 years is dissolved in H2SO4 or H2SO2? It will remain unchanged. Radioactivity is not affected by any chemical change. So option 4 is the correct answer. The half-life of a radioactive material is 20 days. If it is heated to 10,000 Kelvin, then its half-life will become nothing will change. It will remain same because radioactive property do not depend on pressure, volume, temperature change. Okay. So out of four choice, the correct answer is option 4 is the correct answer. The number of active atoms in m gram material is, dear student, number of atoms will be equal to m into Na upon molar mass. So out of four choice, the correct answer is option 4. The activity of a radioactive element decay constant lambda becomes 1/3 of initial activity A naught in 9 years. The decay constant after 9 years, decay constant does not change, decay constant remains same. Okay. It is the property of radioactive element, it will remain lambda. So out of four choice, the correct answer is option 1. It's a very good question in radioactivity. A radioactive sample contains two elements P and Q. The mass of each is 10 power minus 3 kg. The ratio of their atomic weights is 1:3. The half-lives are 4 seconds and 8 seconds respectively. The mass of P and Q after 16 seconds will respectively. Therefore, see here. Now here, there are two elements P and Q. Mass is same 10 power minus 3 kg, 10 power minus 3 kg. And their half-life is 4 seconds and 8 seconds respectively. And time interval is given 16 seconds, 16 seconds, means this is 4 half-life and this is 2 half-life. Dear student, the formula for calculating mass equal to m upon m0 equal to 1 upon 2 power t upon t. So in a time equal to 4 half-life, the mass will become original mass upon 16 and this will become original mass upon 4. So this is 10 power minus 3 kg. So 10 power minus 3 kg upon 16. So this will become 6.25 into 10 power minus 5 kg. And this is 10 power minus 3 kg divided by 4. So this will become 2.5 into 10 power minus 4 kg. So out of four choice, the correct choice is option 2. So we will take option 2 as correct answer. If the quantity of a radioactive material reduces by 10% in 5 days, then the quantity that remains after 20 days will be. Dear student, this is very important property of radioactivity, that percent nuclear decay in same time interval always remains same. Percent nuclear decay in same time interval always remains same. Okay. If this is the graph of N versus T, you can see here, if initial nuclei are N node, in a one half life it will become N node upon 2. Number of nuclei decayed in two half, this is 2T, this will become N node upon 4. So number of nuclei decayed in between 0 to T is N0 upon 2. Number of nuclei decayed between T and 2T, this is N0 upon 4. So number of nuclei decayed are decreasing, but percent nuclei decayed in same time it is also 50%, it is also 50%. We will make use of this property, okay? Percent nuclei decayed of a radioactive element in same time interval always remains same. So dear student, 10% nuclei are getting decayed in 5 days, means 90% nuclei will remain left. If initially 100% nuclei are there, in 5 days 90% will remain left. After another 5 days 90% of the 90%, this is 81%. After another 5 days 90% of initial, that is approximately 72%. And again after 5 days, number of nuclei remaining left is 72 into 0.9, that is approximately 65%. So correct answer is here. In the question it remain left is asked, okay? So you should read the question whether it is asked remaining or decayed, okay? So correct answer is option 3. A radioactive substance has half-life T half equal to 60 minutes. After 3 hours, 3 hours means this is 180 minutes. Means 3 time, okay? 3 half-life. What percent of radioactivity will remain? Dear student, this is the formula to calculate radioactivity. A is in activity at time T. A node is initial activity 1 upon 2 T upon T. In the question, time interval is given 3 time, okay? So this is 1 upon 8. 1 upon 8, if we want to calculate in percentage, this is 12.5%, okay? So answer to the given question is option 3, okay? Answer to the given question is option 3. The weight-based ratio of uranium-238 and lead-206, lead-206, lead-226 in a sample of rock is 4:3. If the half-life of uranium-238 is 4.5 into 10.9 years, then the age of rock. Dear student, in the question, proportion of uranium-238 and lead, which is stable, is given. The proportion is 4:3 in the sample. Means what? Initially, this was 7 and this is 0. And now remaining part, at current time, this is 4 upon 7 and this is 3 upon 4 upon 7 is remaining left, means this is more than 50% remaining left. More than 50% means time will be less than half life, okay? So dear student, the answer to the given question is option 4. Option 4 is the correct choice. Two radioactive substance X and Y initially contain equal number of nuclei. X has half-life of 1 hour and Y has half-life of 2 hours. After 2 hours, The ratio of activity of X to activity of Y is, okay. Now in the question what are given? This is element X, this is element Y. This is also very good question. Initial number of nuclei are same, T equal to 0. This is also N node, this is also N node. And half-life of X is 1 hour and half-life of this is 2 hours. After 2 hours, the time is given 2 hours. 2 hours means how much? This is 2 half-life and this is how much? This is 1 half-life. Okay. Now what is being asked? Ratio of activity. Okay. X is what? Nx lambda x and Ay is what? Ny lambda y. So dear student, if you want to calculate x upon Ay, we will write Nx upon Ny. What is Nx? After 2 hours, this will be N0 upon 4. Lambda x 0.693 upon Tx. This is one. What is Ay? Ny means initial is N0, after 1 half life N0 upon 2. And what is lambda y? 0.693 upon 2y. So 2 to 4, this is 4. So answer will be 1:1. So out of 4 choice, the correct answer is option 3. Out of 4 choice, the correct answer is option 3. Okay. A radioactive sample at any instant has its disintegration rate means dN upon dt 5000 disintegrations per minute. After 5 minutes, the rate is 1250 disintegration per minute. Then the decay constant per minute is. Dear student, in the question, minus dN upon dt. Let us assume at t equal to 0. This is given. This is equal to n0 lambda. This is given 5000. This is equation 1. And now minus dN upon dt at t equal to 5 minutes. Let us assume number of nuclei are n. Lambda will remain same. Okay. This is given 1250 disintegration per minute. So we can calculate here half-life. How? N upon N0 equal to 1250 upon 5000. This is coming 1 upon 4. Means 1 upon 2 power 2. Means 1 upon 2 power t upon t. So dear student, t upon t equal to 2. So t equal to what? 2t. Okay. So half-life is what? 5 upon 2 minute. This is the half-life. Now we can solve the question very easily. Now decay constant is what? Lambda is given as ln2 upon t. So ln2 upon t. This is 2.5 means 0.4 ln2. So out of 4 choice, the correct answer is option 2 is the correct answer. Option 2 is the correct answer. Okay. A specimen of radioactive material contains 10 power 6 radioactive nuclei. Its half-life is 20 seconds. How many nuclei will remain undecayed after 10 seconds? 10 seconds means what? Half of half-life. Okay. Dear student, time interval is given t by 2. And what is relation? N equal to n0 e power minus lambda t. In time interval equal to number of nuclei will become 1 upon root 2. Okay. 1 upon root 2 means 0.707. So dear student, initial nuclei was 10 power 6. So number of nuclei will be 0.707 into 10 power 6. So answer to the given question is 7.07 into 10 power 5. So out of 4 choice, the correct choice is option 2. Option 2 is the correct answer. A nucleus with mass number m and atomic number n emits one alpha particle and one beta particle. Beta means beta minus. The mass number and atomic number of the resulting nucleus will be. Whenever any radioactive element emit alpha particle, its atomic number decreases by 2 and mass number decreases by 4. And whenever any radioactive element emits beta particle, its mass number increases, mass number do not change and atomic number increases by 1. Okay. In any nuclear reactions, charge number and mass number remains unchanged. Okay. So dear student, 1 alpha will make like this. This is the effect of 1 alpha and this is effect of 1 beta. No change. Okay. So here what will happen? This will be Z minus 1. Okay. So this will be atomic number will be n minus 1 and mass number will be m minus 4. So out of 4 choice, the correct answer is option 2 is the correct answer. The nucleus 92x234 decays by emitting 3 alpha and 1 beta particle. The final product is 92x234. When 3 alpha and 1 beta will be emitted, atomic number will decrease by 92 minus 2 into 3. And here atomic number will increase by 1. And here mass number will decrease by 4 into 3. So this is the solution. 93 minus 6. This is 87. And this is how much? 234 minus 12. This is 222. So 87 by 222. Okay, this is the solution of the question. So option 3 is the correct answer. Out of 4 choice, the correct choice is option 3. Okay. In the radioactive decay process of uranium, the initial nuclide is 92 uranium-238. The final nuclide is 82 lead-206. When uranium nucleus decays to lead, then the number of alpha and beta particles emitted respectively will be. Dear student, let us assume X alpha and Y beta are emitted. In nuclear reactions, Z and A remains conserved. So 92 equal to 82 plus 2x minus y. So 2x minus y equal to 10. This is equation 1. And 238 equal to 206 plus 4x. This equation will give us 4x equal to 32. So x equal to 8. If x equal to 8, substitute this. This is 16 minus y equal to 10. So y equal to 6. So 8 alpha and 6 beta is the answer. So out of 4 choice, the correct answer is option 1. Which of the following processes represents a gamma decay? In the process of gamma decay, neither Z changes nor A changes, only energy changes. When gamma ray photon is emitted inside the nucleus, when transition takes place from higher energy orbit to lower energy orbit, then gamma ray photon is emitted. Okay. So ZXA equal to ZXA plus F. This is the solution. Out of 4 choice, the correct choice is option 3.